Let's take a look at this example. This time we have series parallel circuit. We have R1 and C1, resistor and capacitor connected in series, and we have capacitor C2 and resistor R2 connected in parallel. That's why I'm going to call the combination of these two components Z1, impedance 1, and a combination of these two components Z2. Okay, so I can redraw the circuit, and my circuit is going to look like this. This is my Z1, and this is going to be my Z2. Okay? So, what we're supposed to do first? Please notice that we do not have given impedance of the capacitor C1 and impedance of the capacitor C2. So it means we have to find ZC1 and ZC2, impedance of capacitors, or we're supposed to say capacitive reactance of these two capacitors. Okay? So first, in order to find Z total, we're supposed to find ZC1. The formula for impedance of the capacitor is 1 over 2 pi FC. Okay? So I have 1 divided by, open parenthesis, we have 2 pi times the frequency, which is equal to 2 kilohertz, times capacitance C1, which is equal 16 nanofarads. Plugging these values into the calculator, you're supposed to obtain the value of 4.97 kilo ohms. And keep in mind that anytime we talk about the capacitive reactance or impedance of the capacitor, we're supposed to remember about angle of negative 90 degrees or negative J. Okay, but we are going to use polar form most of the time. That's why I use angle negative 90 degrees. Next, we're supposed to find the impedance of capacitor C2. 1 over 2 pi FC2. Please notice that I write always formula first. I want you to write always formula first because this is the only way to remember the formulas. So I have 1 over 2 pi times frequency, which is equal to 2 kilohertz, times the capacitor C2, which is equal 10 nanofarads. Close parenthesis equals, of course, you're supposed to use the calculator, and you're supposed to obtain the value of 7.95 kilo ohms and angle of negative 90 degrees. So I found the impedances of the capacitors. Now we are ready to find the impedance Z1. So we're supposed to simply realize again that these two components are in series. That's why I'm going to write that Z1 is equal R1 plus ZC1, where R1 is equal 14 kilo ohms plus impedance of capacitor 1, which is equal 4.97 kilo ohms and angle of negative 90 degrees. Use the calculator. You're supposed to obtain the value of 14.85 kilo ohms and angle of negative 19.54 degrees. So this is the impedance of these two components together. Next, capacitor C2 and resistor R2. These two components are connected in parallel. That's why we're supposed to use the formula Z2 equals because we have two components, you can use the product over sum. So if R2 times ZC2 over, open parenthesis, R2 plus ZC2, where R2 is equal 10 coulombs times ZC2 is equal 7.95 coulombs, an angle of negative 90 degrees, over 10 kiloohms plus 7.95 kiloohms, an angle of negative 90 degrees. Again, you're supposed to use the calculator. Don't forget about the parentheses. The parentheses in this case, especially in the denominator, are extremely important. You're supposed to get the value of 6.22 kiloohms, an angle of negative 51.51 degrees. We found impedance Z1 and Z2. So you can redraw the circuit, and your circuit right now looks like this. Please notice that these two impedances are in series. So in order to find Z total, we're supposed to simply add them up. We're supposed to write Z total is equal Z1 plus Z2, where Z1 is equal 14.85 kiloohms, an angle of negative 19.54 degrees, plus Z2, which is equal 6.22 kiloohms, an angle of negative 51.51 degrees. Of course, you're supposed to use the calculator, and you're supposed to obtain the value of 20.39 kiloohms and angle of negative 28.83 degrees. This is the value of the total impedance of my circuit. If you want to redraw the circuit, your circuit right now is going to look like this. This is Z total. Okay? Now, using the Ohm's law, we are going to find I total. I total is equal voltage source over Z total, where voltage source is equal 20 volts. Remember, anytime the angle is not given means there is angle 0 degrees. And we have Z total 20.39 kiloohms, an angle of negative 28.83 degrees. This is equal, use the calculator, you're supposed to get the value of 980.87 microamps and angle of 28.83 degrees. This is the value of I total. Okay, so this is the current which will go through the Z total, or current which will go through impedance Z1 and Z2. Okay, remember, in the series circuit, current is always the same. So we can say that I total is equal to IZ1 is equal to IZ2 and is also equal to IR1 and is equal also to IC1. Okay? Please notice that the total current will go through resistor R1 and through capacitor C1. That's why I wrote I total is equal to IR1 and is also equal to IC1. Next, we're supposed to find voltage across resistor R1, because we found that the current which goes through resistor R1 is equal to I total, I'm going to use Ohm's law again, but this time for voltage, and I'm going to write VR1 is equal I R1 times R1. Remember, voltage is equal current times resistance, where IR1 we set is equal 980.87 microamps and angle of 28.83 degrees times R1, which is equal 14 kiloohms. Okay, use the calculator. You're supposed to get the value 13.73 volts and angle of 28.83 degrees. Okay, so this is the voltage across resistor R1. Next, we're supposed to find the current which goes through resistor R2. Now, this time, we're going to use the current division law, okay? Remember, this is my I total. I total is going to go up to this point, okay? At this point, is going to split into the current IC2 and IR2, okay? Remember that the parallel circuit is going to divide the current. That's why I'm going to use the current division law. Why I'm going to use current division law? Because I want you to practice it. I have IR2 is equal I total times Z2 over R2, where I total is equal 980.87 microamps and angle of 28.83 degrees times Z2, which is equal 6.22 kiloohms and angle of negative 51.51 degrees over R2, where R2 is equal 10 kiloohms. Plugging these values into the calculator, you're supposed to obtain the value of 610 microamps and angle of negative 22.68 degrees. So this is the current which will go through resistor R2. So basically we can say that we found everything, whatever we were supposed to find, and we can say that the problem is solved.